Processors reside at the heart of our cars, laptops, cell phones, wearables, and also in the cloud. It is hard to imagine our life without them. Instead, we like to imagine our life with faster and longer-lasting devices. Then, the key question is, how do we keep improving the processors? Broadly speaking, there are two types of processors. On the one hand, general-purpose processors can run many different applications reasonably well. On the other hand, specialized accelerators can run only a few applications, but very fast or efficiently. Lately, the trend is to try to combine both strategies by putting multiple specialized chips together. To achieve this, however, it is crucial to have a fast and versatile interconnect, allowing chips to share data and synchronize. The problem is that, because of its wired nature, current interconnects are simply not good enough. One reason is that they are bad at transmitting data from one chip to many. Another reason is that they are rigid and hard to adapt to different applications. This eventually leads to using many more wires than strictly necessary to cover all possible applications, a phenomenon called over-provisioning. In this context, the project Whiplash aims to solve the interconnect problem with the help of nanotechnology and wireless communications. Whiplash envisages that each chip will be equipped with one or more antennas, allowing to send data wirelessly within and across chips. The wireless approach is broadcast-friendly, because wireless transmissions can reach all antennas at the same time. Versatile, because the wireless connections can be reconfigured on the fly. Modular, because new chips can be added with relative ease. This level of integration is possible thanks to the unique properties of graphene, an extraordinary 2D nanomaterial. In particular, we propose to use graphene in the antennas, which become 10 to 100 times smaller than the conventional ones, allowing them to fit within the chips. Tunable, allowing us to change frequency and direction of the transmissions. And ultra-fast, allowing to transmit in terabits per second. Thanks to these antennas, we can have ultra-fast and reconfigurable wireless networks at the chip scale. These will enable the design of new processors that, for the first time, are as fast and efficient as specialized processors, but as versatile as general-purpose ones. From a technical point of view, Whiplash touches upon three critical aspects: the antenna, the wireless network, and the processor architecture. At the antenna level, in Whiplash, we work to build a graphene antenna and integrate it into an environment similar to a processor. This way, we will demonstrate for the first time that graphene antennas are practical. At the network level, in Whiplash, we investigate how electromagnetic waves propagate through a chip. We also design protocols to allow antennas to communicate efficiently in the chip scenario, where wireless communications have never been to. At the computer architecture level, in Whiplash, we design new processors that would exploit the advantages of wireless communication to be faster and more efficient. We aim to demonstrate that we can execute neural networks at least 10 times faster than the best processors today. Finally, to understand if future processors using antennas will be able to yield such an improvement, in Whiplash, we are developing a cross-cutting simulator containing, for the first time, models of all the unique elements developed in the project. Such an interdisciplinary undertaking is possible thanks to an excellent team composed by members of a deep tech SME, an industry leader, and 5 top-tier academic institutions. Whiplash thus gathers the expertise to carry out graphene integration, antenna development, wireless communications design, and processor architecture design. If successful, Whiplash will lay the foundation for a new generation of processors. This will contribute to the technological sovereignty of Europe in the chip manufacturing industry and beyond, with a strong impact on strategic fields such as artificial intelligence, healthcare, the Internet of Things, or the automotive industry.